Don't forget to like, subscribe and share the videos.
The topic that we are going to discuss now is reciprocity and non-reciprocity. What is reciprocity? What is non-reciprocity? What are its definition? What are its applications? And other details we need to understand. Okay? Reciprocity. Scientists have developed devices which break the principle of reciprocity. Okay? There is a principle called reciprocity principle, and recently scientists have developed devices which break this principle. Thus, they are going to tackle challenges that arises out of this reciprocity phenomenon. So, from this statement itself, we can understand that reciprocity finds many applications, but it also has some inherent challenges, some problems that these scientists have addressed. Okay, let us see in detail. First, the concept of reciprocity. What is reciprocity? It means if a signal is sent from one point to another, it is sent back from the second point to the first point. This is called as reciprocity. Say for example, there are 2 points. If signal is sent from this point to this point, say 1 and 2, then it will be sent back from point 2 to point 1. Okay, that is called as reciprocity. But there are situations where reciprocity does not work as expected. Okay, the best example for this is, you might have watched in some movies that a person being questioned or interrogated can't see the police officers through a window, but the officers can see them. Okay, so if you see that in the picture, those are called as interrogation rooms. So in this room, this is the interrogation room that we are talking about. Here you find a mirror. For people who are sitting inside this room, it will be looking as a mirror. But for the people who are on the other side of the room, for them it will be like a window, a transparent window. So for people who are here, it is a mirror, and for people who are in the other room, it is a transparent window. This is called as non-reciprocity. Okay, so this is where the reciprocity concept fails. Okay, that is called as non-reciprocity. The physics of letting waves to go in one way but not the other. So there the light waves are allowed one way, but it is not allowed the other way. That is why it is acting as mirror one side and as a transparent window the other side. Okay, so this is non-reciprocity. Now let us get into the details of the applications of reciprocity. Where are we using reciprocity concept? First thing is antenna testing. Reciprocity simplifies antenna testing. How? This reciprocity helps to determine the antenna's ability to receive signals from different directions, which is known as far field pattern. Okay, antennas will be tested using this reciprocity concept. Okay, it will be receiving signals from different direction, and they will test whether the signals are transmitted back or not. Okay, so this is how antennas are tested, and reciprocity concept helps there. Next is radar system. Engineers use this reciprocity concept in radar system to test and operate the system, and by studying how the radar antennas work, okay, how they send and receive signals, they can actually improve the system's performance and accuracy. And what is radar? Radar is electromagnetic sensor which are used for detecting, locating, tracking and recognizing objects of various kinds which are at a considerable distance. Okay, so that is radar system. Thus in radar system also the concept of reciprocity is used. Next is sonar system. What are sonar system? In sonar technology, which is used in underwater detection and navigation. Okay, so the sonar system is used in underwater detection and navigation. Even there, this reciprocity will aid in testing and optimizing the performance of these sonar devices. Okay, and then even in seismic surveys, reciprocity concept is used. How? It will simplify the testing and operation of seismic survey equipments which are used in geology and oil exploration to study the subsurface structures. Okay, so seismic surveys like subsurface structures will be studied using the signals that are got from the seismic equipments. Okay, next is medical imaging. Even in MRI like scanners, this reciprocity concept is used, and these scanners utilize this principle to send and receive signals for creating detailed medical images of the human body. Okay, so these are the applications of reciprocity. Now let us see what are all the challenges of reciprocity phenomenon. First thing is spying and information security. How is it going to affect spying and information security? Because what is reciprocity? It means while one can receive signal from the target, his own equipment may unintentionally transmit signals which potentially expose his location and intention. Say for example, a person is doing a stealth operation and he is sending a signal here, and this signal, a signal to find him is being sent, okay, but he should not be detected there in that radar. But this reciprocity concept will actually expose his location and intention. So this is a drawback with respect to reciprocity equipments, this phenomenon. Next is back reflections may also happen. Okay, when we are going to use high power lasers for signal transmission, then the imperfections in the transmission line can lead to harmful back reflections. So the transmission lines will be having certain imperfections, and those imperfections will cause something called as back reflections, and these back reflections could re-enter the laser, which will potentially cause damage and it will interfere with signal. Okay, so thus it will cause signal degradation. Okay, so this is how the back reflection is happening, and it is a challenge of reciprocity. Next, we have signal amplification for quantum computing. What is signal amplification and how is it used in quantum computing? We all know that quantum computers use extremely sensitive qubits. Okay, these are the basic units of quantum computing, that these qubits need to be maintained at very low temperatures. Okay, that is the basic condition. But to sense their quantum states, whose quantum states? The qubits quantum states, the signals must be amplified significantly. But this amplification process is hampered by this reciprocity concept. How the reciprocity can introduce challenges in achieving efficient and controlled signal amplification without noise or unwanted interaction. So there will be noise and unwanted interactions due to this reciprocity concept. Next is miniaturization. These days we are focusing more on miniaturization, that is we are taking everything to nano level and micro level. So when we go to nano level and micro level, then ensuring signal efficiency and control becomes increasingly challenging because of these reciprocity concepts. Okay, so these are the challenges in reciprocity, and what is the solution that the scientists have recently found? One best solution they have found is magnet based non-reciprocal devices, okay, which consists components like wave plates and Faraday rotators. What are these Faraday rotators? They use magnetic material which allows wave to pass in one direction, but it blocks them in the reverse direction. Okay, like we saw in the definition of non-reciprocity, it works exactly like that. These Faraday rotators work exactly based on the principle of non-reciprocity. Okay, so thus it breaks the principle of reciprocity, and this is how scientists have created a new device. Okay, so this is what you need to know about reciprocity.